In this lesson, we are going to be looking at the line of best fit. We usually draw the line of best fit by eye, and it roughly needs to have an equal number of points above and below the line. In these examples, you can see here we have a strong positive correlation, a weak positive correlation, a strong negative correlation, and a weak negative correlation. As you can see from it, the stronger the correlation, the closer the points are to the line. However, you also do need to think about the zoomed inness of the graph. So if the points are, they could look far apart because there are few points at a very, very large scale. So just make sure you do look at the scale when you are deciding whether it's strong or weak. If the gradient is positive, the correlation is positive, and if the gradient is negative, the correlation is also negative. When drawing a line of best fit, remember the following points. It does not have to pass through the origin. The line of best fit can be used to predict one variable from another, and when we do that, we always need to make sure that the predictions are not outside of the range of the data used. I'm going to show you some examples. So, if I have this graph, we looked at this right at the very beginning of the previous video. The graph shows the relationship between life expectancy and the number of cigarettes smoked in a week. So there is my line of best fit. It is roughly between each of the points. Here it is just transposed. So, work out an estimate for the equation of the line of best fit using the gradient and intercept. We are not going to worry about that. But if I was going to make a prediction on here, if I was going to say, I wonder what the life expectancy of a person who smokes 20 cigarettes in a week will be, then I'd go to 20, I'd go straight up and then straight across, and it looks like it'll be about 67 years old or 68 years old. So if you would just read it off, you would just draw in a line straight up and straight across, and you'd be able to read off. Now you wouldn't be able to make a prediction of anyone if they smoked more than 100, because that is the last amount of data that we have in our information. So if we're going to say who smokes 10 cigarettes a day, I'd go from 10, I'd go all the way up, and it would be about 71 years. Why would an estimate of the number of cigarettes smoked for a life expectancy of 40 years not be reliable? Well, there's quite a lot of data here, and it's quite spread out at that point. Can you explain why there are so many outliers for this data? Well, what do you think? Have a little think about it and then push pause and then come back here. So why are there so many outliers? Obviously, it's other health conditions that would cause people to have a different life expectancy. So it's not just the smoking of cigarettes, and we would need to know about other lifestyle things had by this person. There could be other factors in whether they have a long life or a short life. Now, that'll be next one.